The scalar product of vectors is a way to multiply vectors. Vector A multiplied by vector B. Remember, product in maths just means multiply. And a scalar is not a vector, so it has a magnitude only. Magnitude only. So it's a number. So there are actually two ways to multiply vectors: the scalar product and the vector product. You're not going to learn about the vector product, you're just going to learn about the scalar product, which we write as A dot B. A dot B. There is another way to do this, A cross B. So this is a traditional multiply sign, but it actually means the vector product. So we're not doing this. Okay, so ignore the vector product. Scalar product is called the scalar product because A dot B, when we get an answer, it will be a scalar. So you will get a number out rather than a vector. And the other method for finding the vector product, you multiply two vectors and get a vector. That's beyond this course. Working out A dot B, there is a formula to work out A dot B. It is the magnitude of A multiplied by the magnitude of B cos theta. Cos theta is the angle between the vectors. Vector A has to be drawn coming out from the same place as vector B. So the arrows start from origin going outwards, like this. Do not use vector A going this way, vector B. So you're not going to use that. Vectors must always point away from the vectors. Vertex. The vertex is just a corner, so the vectors are pointing away from this, going out. So check that before you start. If I have vector A as magnitude 4, and vector B has magnitude 5, A and B, and they have an angle of 60 separating them. So we can find A dot B, magnitude A, magnitude B, cos theta. Just put in the magnitudes, 4 multiplied by 5 multiplied by cos 60. Work this out and we have 10. That's our scalar product. This is just a number, not a vector. If we begin with A and B in this orientation, and the angle is 30 between them, magnitude A is 12, and magnitude B is 10. Now we can calculate A dot B, but we have to be careful before we start because A and B are not coming out from the same vertex. So we can just move vector A along here. We keep it in the same direction and also the same length. Vectors can be moved around like this. Now we calculate this angle between A and B. A and A are in a straight line because they're parallel. So this red angle must be 180 subtract 30, 150 degrees. We use 150 degrees in the scalar product. So A dot B equals magnitude A, magnitude B, cos theta. 12 times 10 times cos 150. Now please notice always cos for the scalar product. And our answer is negative 103.9. That's our scalar product. It doesn't have any units. And it's okay for it to be negative. In fact, you would expect it to be negative if the angle is between 90 and 180. So this value is negative when theta is between 90 and 180 degrees. Okay, what happens if theta is 90 degrees? If the two vectors are perpendicular? Just a rough sketch, AB perpendicular. So A dot B equals magnitude A, magnitude B, cos theta. It doesn't matter what the magnitudes are. We can just put cos 90, and remember that cos 90 is equal to 0. So we're doing magnitude A, magnitude B multiplied by 0. So this means the whole right hand side is 0. A dot B is equal to 0 when A is perpendicular to B. This is an important property when cos 90, perpendicular vectors. There is another way to work out the scalar product, and that's the component form. If you're given vector A and B, A is A1, A2, A3, these numbers, and B is B1, B2, B3, some numbers. We can use the vectors, so the component forms of the vectors, to work out A dot B by doing A1, B1, multiplying the x's together, multiply the y's, A2, B2, and multiply the z's, A3, B3. For example, we have vector A, 2, negative 3, 5, and vector B is 4, 1, 7. Multiply these up. Use the x's, 2 and the 4. Multiply these, 2 times 4. Then we add negative 3 multiplied by 1. Then we add 5 times 7. Work out this number. 2 times 4 is 8. Then this is negative 3 plus 35. So our final answer is 40. So there's two options for working out the scalar product. Just use whichever one is possible with the information you're given in the question. Calculate the scalar product for A, which is 4i plus 2j plus k, and B, 3i subtract 3j subtract 6k. scalar product A dot B. We'll use the components. Change A into the components 4, 2, 1, and B into its components 3, -3, -6. A dot B, multiply the components and add them. X components are 4 multiplied by 3, then add 2 multiplied by -3, then add 1 multiplied by -6. We have 12 subtract 6, which is 0. Therefore, A dot B equals 0. This is important because that means vector A is perpendicular to vector B.